Hello everybody, today we're going to have a look at solving some trigonometric equations. So the first one is a graphical one. So solve cosine x equals 0.4, and we've got a boundary here of 0 to 10, and we're in radians, and we can use the graph in front of us. So what we want to do here is we want to kind of find where 0.4 is, and we want to draw a line through that point. Please forgive my not very straight line. Okay, so there's 0.4. So we want to know when this thing is 0.4. So all we need to do is just look at where that happens. So if we look down, okay, we've got a point here. We've got another one here. And we have a third solution here as well. So we have three different solutions. Let's try and read this off. Very roughly, using an estimate only, we could say that x is equal to 1.15. Maybe we could say x is equal to 5.1. And from this one, we would probably say that we've got about x is equal to 7.4. Okay, if you're doing a graphical question, you've got the graph in front of you, there's going to be some sort of margin for error here. Okay, so be as accurate as you can. Right, moving on, let's try to do some things a little bit in a different way. This one, the important thing is here to recognize is that we don't have the skills to do this without a calculator at the moment. There is no way, okay? I'm doing this for you with not a lot of content taught, and even if it was taught, we're never going to have the amount of skills necessary to solve this. So we're going to cheat. We're going to use a calculator. We are going to plot an intersection, okay? So we're going to press y equals, and we're going to type in our first one, which is y1 equals 2 sine x minus cosine x. We are going to plot that y2 is going to be 4 minus x. We are going to use the window feature to set the boundary, right? Now I would go, if we're looking at a boundary of 0 to 2 pi, I would start by saying perhaps the x minimum of 0 and x maximum is maybe 7, okay? Because of course, remember pi is 3.14, so 7 seems like a good maximum, and maybe we want to reduce and change our boundary. Now, this right-hand equation, the 4 minus x, indicates to me that my y max is going to only be 4, because it's going to be where it crosses the y-axis, and it's going down. We've got negative gradient, and from there, I don't know what you want to do. The y min doesn't really matter at this point. Let's just say minus 4. So I would be looking at this and using logic to say, right, okay, there's my window, there's my intersection. Now, I don't have any screen captures of the graph today, but broadly speaking, what we're seeing is we're going to see something along these lines. Okay, you're going to have something like this. Who knows? Okay, something like that. Okay, and if we find those intersection points, we can hopefully find that they are x is equal to 1.82, x is equal to 3.28, and x is equal to 5.81. Yeah, okay, we're using the intersection feature on our calculators. Okay, now then, here is where our real work begins though, okay, because you will have to do non-calculator questions, and they look mean, and we're going to start with some easy ones though, and we're going to build up and build up and build up over the next few videos. So let's get straight into this with cosine x equals minus root 3 over 2. Now, as soon as you see anything to do with minuses and pluses and root 3s and 2s and halves and things like that, we are instantly thinking about the unit circle. And if we imagine our unit circle, well, cosine is going to be our x-axis, right? So we are kind of expecting our x-axis, okay, to be minus root 3 over 2, right? Okay, that point there, minus root 3 over 2. So that means if I was to draw my unit circle around it, there's going to be two different values of theta. We've got one there, look, and we've got one round here, which are going to provide us with this. Now then, this will be true. Well, this is the longer length of our special triangle, if you like. Okay, so this is going to happen when we have an angle in here of pi over 6, which means that our original angle must have been, in this case, is x rather than theta. X is equal to 5 pi over 6 if we're rotating from that x-axis, right, that positive x-axis. And then our other one is going to be if we have our pi and we add that pi over 6 onto that pi. So we're going to have another solution at 7 pi over 6. So there is our answer for A. Right, for B, it's similar, okay, similar in style. We could very easily rearrange this function to be sine x is equal to a half by adding 1 to both sides and then dividing by 2. So sine of x is going to be like our y coordinate, right? So imagine we've got a half there, look, as our y coordinate in our unit circle. That is going to happen in 2 different places, isn't it, right? We've got an angle of theta that is in the first quadrant and again in the second quadrant there, right? So how will that look? Well, think of it as the special triangles again. If we zoom in on that, right, we know that that length there is a half, right? Okay, the longer length, root 3 over 2, is on the x-axis. This again is going to be pi over 6. So we do have a solution already. X is equal to pi over 6. We can find this other point. Well, it's the same reflection. We could go back pi over 6, right, on from where pi was. So our other solution is going to be at 5 pi over 6. Next one. Okay, now tans are a little more tricky, but it's good to remember that a tan graph repeats itself every 180 degrees or every pi radians, right? So we can use that fact to help us. So if I'm going to be drawing this tan graph and I'm thinking about tan, well, we are going to draw the unit circle, certainly, but we've got to think about what will create a tan of negative a root 3, right? So, of course, by rearranging this, we can see tan x is equal to negative root 3. So think of tan x as being sine x over cosine x. And even better than thinking of that, think of it as being the y coordinate in the unit circle divided by the x coordinate. So when would I get a negative root 3? Or in fact, when would I get a root 3 at all? Well, if we think of our key features, we could very easily imagine sine x is root 3 over 2, and cosine x is going to be a half. And if we work that out, that will actually give us a root 3. So we could easily plot that point. It's not negative, but it is certainly very, very helpful, right? Okay, so that is certainly true. But if we're going to be negative, well, we need one to be positive, one to be negative, and that is going to happen in the second quadrant and in the fourth quadrant. So our answer is definitely going to fall into there. So if we wanted our sine x to be positive root 3 over 2, that's the longer length of our special triangle, right? Okay, so we could have root 3 over 2 there, look, a half there. So when does that occur? Well, that is going to be, again, if you think of the special triangle, we'll have pi over 6 there, plus that original 90 degrees or pi over 2. So if we add those together, we're going to end up with our first solution. Okay, that theta that you're seeing there, okay, or x, is going to be 2 pi over 3. Now, as it repeats every 180 or every pi, we can get our second solution in the fourth quadrant by just adding to that, okay? So we can say we've got, okay, another one here at 5 pi over 3 as well, right? So those are going to be our solutions for that particular question. Okay, there we go. Have a look at these questions. Good luck.